Parallel transversals, what are they? Well, parallel transversals just basically means that we have a transversal, which is, again, a line, okay, that cuts into two or more lines, right? And these two lines that it's hitting, okay, are going to be parallel, all right? And so that's going to look something like this, right? Where I have two lines that are parallel and one line that is cutting through those, okay? Now, it doesn't matter which way this line cuts through. It can cut this way or it can cut straight down, but it is creating some angles, right? We have 8 different angles that it creates because there are two lines that are being intersected. The one way we know that this is in particular parallel lines is usually you will see some type of arrow here, okay, that will show us that they're parallel, all right? Now, if they're parallel, there's certain things that exist, okay? There are certain properties that exist, and that's where I want to go back and look at this real quick. We will have some congruent pairs, okay? And so our congruent pairs are going to be our corresponding angles. They're going to be the same measurement. That's what congruent means. Alternate exterior, right? Alternate interior, and vertical, which, you know, vertical are always congruent, but they still play a role here. And then we have some supplementary pairs. And what does supplementary mean? 180. So 180 degrees. So we have linear pairs, which exist, and we also have same side interior pairs, or sometimes you'll see those referred to as consecutive interior, which just basically means that they're right beside each other and they're on the inside of the transversal. And those will be supplementary, which means that they will add together to give you 180 degrees. All right, so let's move into here. One thing that I think sometimes helps us is if I know what is congruent. And sometimes that helps by just identifying the angles. So if I said, hey, there's an angle that's formed right there. There's this angle that's right beside it, or across from it, my bad, that is congruent to it, right? Because it's vertical. And this here little zigzag pattern kind of continues all the way down through. And so if you look, anywhere there is a dot, those angles are going to be the same as each other, all right? All those angles will be the same as each other. And that kind of goes and holds true for the other side as well. So if I see a dot on this side of this angle right here is going to be the same as this angle right here, and it's going to be the same as this angle right here, and it's going to be the same as this angle down here. And so that little zigzag pattern is there, and it's one way that will help you whenever you try to do problems. If you do the zigzag pattern first, you'll know whether or not they're the same or whether or not they're different. Now, one thing that you need to realize is that whatever the angle measurement is, so let's just give you an example here. If I said that this angle right here was 60 degrees, okay, well that means that everywhere that there's a purple dot, that is going to be 60, okay, because of what I said, that there are congruent angles. And the reason why they're congruent is because of some proofs, but the big thing is to understand that, hey, these are vertical, so they're congruent to each other. Or, hey, this is corresponding, so guess what? Those are congruent to each other because of what I said earlier. These are alternate exterior. Hey, they're congruent. Alternate interior, they're congruent. So there are these things that exist. But the big thing is if you know one of the angles, then you can find all the other ones. Because this right here at the top is a linear pair. And so since it's a linear pair, that would mean that they make 180 degrees. So that would mean that this is 120. And that everywhere a green dot would be 120. So that is important to understand. It's important to understand that there is a pattern here, which makes it a lot easier to solve problems. So let's look at some problems where we're actually going to see some x's, okay, where we need to solve, okay? So let's take a look at this. So here's an example where we have to solve for x. Now, hey, if you haven't noticed, in geometry, things are either going to be equal to each other, they're going to be equal to 180 degrees, they may be equal to 90, but those are about it. And so that's kind of what we're going to do here. We're just going to notice what kind of angles we have. And so sometimes it's best just to understand which type of angles you have. And so I'm going to start by doing that. So if I look at this particular problem, what type of angle is this and this together? Well, those are corresponding angles. So you want to go back and you want to look at what corresponding angles are if you have no idea what I'm talking about. But corresponding angles are going to be congruent when there are lines that are parallel and cut by a transversal. And I know they're parallel because I got an arrow, right? Now, if you look, this falls on the dots, right? The zigzag dots. So that tells me that those two angles are congruent. Also, those two angles appear to be obtuse, all right? Something else that allows you to kind of know, hey, look, those things are going to be the same. And since they're the same and they're congruent, then that means that I can go ahead and I can set up an equation where 11x minus 4 is going to equal 95. All right? I kind of got carried away over here, but I'm pretty sure that says 95. Yep, good. Okay, just making sure all that's the same. All right, now let's go ahead and solve this real quick together, all right? So if I'm going to do that, I'd like to go ahead and just draw my line down through there and just do the algebra. So we're going to add 4 to both sides, and that's going to give us a 99, okay, on this side. And it's going to give us 11x, which means that x is going to be 9, all right? And so that's how you solve for x. So it depends. Sometimes, though, it's 180 degrees. So let's take a look at the next problem and see. All right, so looking at these two angles, again, I want to know what type of angles they are. You know, together, they're the particular type that's called same side interior because they're located on the inside and they're on the same side. So when we go back to our rules, same side interior are always supplementary, which means that they're going to equal 180 degrees, right? Instead of being congruent. And if you notice, they don't fall on the same zigzag, right? This guy is on a different one, and which means that they're actually going to be supplementary. And so we can do this. 7x plus 11 plus 120 equals 180 degrees. All right. So if I add 120 and 11, because those are my like terms, I will get 131, which equals 180, right? All right, so we always want to make sure, we always want to get our calculator and just make sure, because otherwise we may get things wrong, right? So 11 plus 120 is obviously 131, but I want to go ahead and take that to the other side, right? So I want to subtract it. And so when I do that, I'm going to get 7x is equal to 180 minus 131, which is going to be, we always want to check in our calculator, right? I always want to make sure. It's going to be 49. And so that means when I divide by 7, x will equal 7. And so that's how we solve for x when things are supplementary. All right? So sometimes, though, we have to plug it back in to find the measurements of angles. And so let's look at a problem like that for our last example, where we're going to find the measure of the angle that's indicated in bold, which would be this one. Okay? Now, these two angles, we got to start with that. These two angles are alternate interior, okay? Because they're alternating between the sides. So they are alternate interior. Now, when we have alternate interior angles, we should know that they are the same, because that's the idea of what we've talked about before. So if they're the same, that means they're congruent, right? And they're congruent because they fall on that same diagonal, that same thing that we've talked about before with the zigzag, right? So they are equal to each other. And so we can set up an equation where 19x plus 1 equals 20x minus 5. And we're going to go ahead and try to solve this, right? So I always say take your x's to the left. So boom, take it over there. So we're going to subtract it because it's positive. Boom. So that gives me negative 1x plus 1 equals negative 5. Subtract 1. Again, always use your calculator just to make sure you guys have this right, because you want to make sure that your numbers are correct. So then divide by negative 1. Ran out of room there. I'm going to go ahead and put it over here. Negative 1x equals negative 6. We're going to divide by negative 1, which gives us x being positive 6. All right? Now, I'm not done yet, and a lot of times when you see multiple choice questions, they'll give you that as an answer because they're trying to trick you. Since I'm trying to find the angle, though, I'm going to go ahead and plug that x back into that particular problem. I don't need to plug it into the other one. I just need to plug it into the one I'm looking for. And so to do that, I do 19 times 6 plus 1. All right? So take your calculator, do 19 times 6 plus 1, making sure that you have it correct. 19 times 6 is 114, plus 1 is going to be 115. And so that means that this thing is 115 degrees. And that's how you solve problems that involve transversals, parallel transversals. Now, if they're not parallel, then these items that we talked about, they don't exist. And so that's how you know, though, all right, if they're parallel and they have those arrows there and they're parallel. And then we have things such as angles that are congruent and angles that are supplementary.